Okay. Oops. Okay, is that showing up okay?
Yeah, looks great.
Okay. I'm going to talk a bit about the crazy project that we're working on. This is a bit more of a manifesto than an actual research talk. Again, like a lot of us, we lost an entire field season to COVID last year. So we've got plans, we've got some preliminary data, and that's what I'm going to show you today. But come back to me in a couple of years for a much more complete story. So I work with invasions, but I've also worked for a number of years in high latitudes and a number of issues. And I've gotten interested in the question of invaders at high latitudes in Canada. And to give you an idea here, I mean, as you might expect, most invasive plants in Canada are found in the south. So in the Greater Toronto area down here, where I'm speaking from, about 40% of our plants are non-native in origin. Here are some other sites where I've worked. The Kotanen Scientific Reserve, about an hour north of here, 28% are exotic. Even in Algonquin Park, which is a large natural environment park, about 26% are exotic. But then by the time you get up here, we're down to 2%. And that's probably typical for a lot of this kind of latitude. So somewhere between here and here, we have hundreds of non-native species dropping out of the system. And in fact, by the time you get up to the coast of Hudson Bay, there are very, very few non-native plants occurring there anymore, with one exception. That's right here, Churchill, Manitoba, 58 degrees north. There are about 107 exotic plants that have been recorded from there, about 20% of the flora. This is a gigantic outlier compared to what we would actually expect. There's a reason for that. Now, this is a different kind of urban ecology. Churchill is only about 900 people, but that's actually significant by Northern Canadian standards. It's about 250 kilometers in any direction to a larger town from here. It's got quite a long history. It started in European settlements, started in the 1600s. And again, we've had more than 100 non-native plants. Most of these immediately discover they've made a horrible mistake and die, but there are about 20 or 30 species that are persistent. Yet almost all of these are restricted to the town site, to the actual town site itself. Churchill is right at the boundary between boreal forest and tundra. Almost none of these have actually escaped the town site into the surrounding environment. The question we're interested in is why. By the way, just as an aside, 58 degrees isn't so far north by European standards, but it is by North American standards. The main reason that Churchill is known is that it's the place you go in North America to see polar bears. So we really are at the edge of good quality tundra here. Well, there are a number of explanations for this. The first is simply probable pressure. Now that explains why a lot of these exotics are there in the first place. There's been a Hudson Bay Company post in 1717. There's been railway access, and Churchill's been a grain port since 1929. For a while, it was a military base. It still is the only ground access to Hudson Bay. We think most of these invaders probably came in with grain being shipped into the grain elevators, which is still sort of ground zero for invasions. But we also know that many of these things have been there for decades. There have been a series of surveys going back about 60 years. And many of the species that we see now have been consistently present in the area for that entire period. Some of them abundantly flower. Some of them produce abundant seed. So philosophy, for example, produces tons of seed. And yet it hasn't really escaped the town site. It still seems to be confined to this very restricted area. We thought of disturbance. And the town site, as you might expect, is highly disturbed, and in fact includes dumps and waste areas. But this area has got a long history of use, in fact, by, again, the military. There's a local road network. There are railway yards. Almost all of these are invader-free. It's really hard to find any of these things outside of the actual town footprint. It's possible that there might be a role for natural enemies. Settlements can have reduced herbivory. And it's possible that towns like Church or little islands have reduced damage in the landscape. This is really hard to test, unfortunately, since most invaders are only present in developed sites, so there aren't many controls to look at. As well, damage levels in northern sites tend to be really low. So we do have a little bit of evidence. So for example, here are some data for common dandelion, which occurs. Traxicum officinale is introduced. Traxicum lacerum is actually an Arctic native that's present as well. We have evidence that as you go further north from southern Ontario to northern Ontario, damage levels rapidly drop. There might be some hint that the native dandelion has less damage than the exotic dandelion, but we just can't find the exotic dandelion out of town. And again, damage levels are really low. Again, only a couple of percent. We've been starting to look at soil feedback. We've been wondering if invaders are changing the soil in such a way as to benefit their own growth. We've done a pilot experiment using this, Linaria, butter and eggs. This may be the northernmost stand in North America for this species. So last summer, even though we couldn't make it to the field site, we managed to have soil shipped to us from invaded and uninvaded sites. Have used to inoculate them and grow plants in greenhouse in the presence and absence of invaded soil. And there is a hint there's something going on. Live soil, that is soil collected from invaded or from soil that hasn't been sterilized, seems to actually support more growth than sterilized soil. So it looks like there probably are beneficial organisms in the soil that are affecting growth. So far, though, there's no hint that there's a benefit in invaded versus uninvaded areas. Again, red's invaded, blue is uninvaded. We're repeating this experiment on a much bigger scale, so we've got a better understanding of whether the soil community is having an effect. But so far, it's not looking promising as an explanation for why invaders can't survive outside of town. There have been a number of studies now that have looked at soil nutrients. I mean, this is one of our first hypotheses. You know, urban areas tend to be very enriched. So we've been comparing both invaded and uninvaded areas in terms of various soil nutrients. This is another study that actually was done before us. But again, there aren't a lot of clear patterns. Probably nitrogen and phosphorus are the most limiting nutrients on site. There are some hints that these are elevated in invaded areas, but it's not a very consistent pattern, and most of the statistics so far have been non-significant. Phosphorus is maybe the most promising one. We've repeated this, but we're not finding very clear patterns. Finally, microclimate. As an observation, a lot of these invaders seem to occur in sheltered or south-facing areas. So for example, here's a little town park that's full of white clover, Trifolium repens. There's a little evidence that this may actually be significant. So for example, here's a survey we did looking at the locations of common dandelion and the native dandelion, Traxicum lacerum. And what we did is we located buildings and simply searched around the edges of buildings and asked for each face of the building, where do you find plants? The Traxicum officinale, the invasive dandelion, is really strongly concentrated on the south sides of buildings. So it looks like it may actually be occurring in warm microhabitats in this environment. The pattern's much less obvious for native dandelions. So the message of all of this is that we've sort of done the survey work, and there's not a lot that's leaping out at us at this point. The next step we're going to try doing, hopefully starting late this year, is we're going to try to tackle these problems experimentally. We're working at this site at the left, the Churchill Northern Study Center, which is about 25 kilometers out of town. We've got permission to look at some of these problems experimentally. So we're going to be setting up plots where we can actually add fertilizer, herbivore protection, and also seeds or propagules and assess performance. We're also hoping to create temporary greenhouses to locally elevate temperature as well. So we're hoping we can actually take an experimental look at some of these things and say, here's an environment where none of these invaders are currently surviving. What do we have to add before they can actually survive? So why are we doing all this? Well, there are a couple of reasons. One is just that it's interesting. I mean, Churchill's the point that spoils everybody's regression in this massive outlier. But here's the other concern. Canada's climate's rapidly warming, especially in the north. So again, here are just predictions for winter temperatures for northern Canada. Actually, yeah, these are winter temperatures for northern Canada. There's already a lot of warming going on in the Northwest. We're expecting to see very rapid warming in the Hudson Bay area in the next few decades. Our original hypothesis was temperature might be the limiting factor for these plants. And if it's as simple as that, then it may be that as the temperature increases, all these plants that are currently restricted very much to inhabited areas may wind up invading these currently pristine tundra and boreal habitats. But if that's not it, if the explanation in fact lies with soil nutrients or microbiota or some other factor, then these habitats may prove much more resistant to invasion in the long term. Either way, towns like Churchill are anomalies, but they also may be foci for these invasions. And like I say, this is the biggest town in 250 kilometers in any direction. So if they're going to be invaders invading natural habitats, this is where they're going to be coming from. We're hoping in the next few years that the experiments we do are going to provide critical evidence on what's limiting these invaders now and on the chance that they're going to escape as conditions continue to change. Anyway, that's what we're planning, but I wanted to give you an idea of what's on our horizon.